Okay, maybe we start, and if people later come in, that's no problem. So, thanks. So, hello, welcome everybody. My name is Nora Kluge, and I work at the Federal Office for Information Security, which is called BSI in Germany. And I would like to say hello and welcome everybody. Nice that you are here. Since we have international guests and international audience, and we would like to have international outreach, the event will be in English. I hope it's okay for everybody. And we already had a disclaimer that the event is being recorded, but only the speakers are being recorded, so you cannot switch off your cameras, and then you won't be seen. Yeah, thanks, Marcel. The next slide. So we are here, or why am I here? First of all, I am the project manager of the project Dialog on cybersecurity, which is kind of the background and the origin of this work stream and this format. And Dialog is our annual dialogue format in which we which is a participative process, yes, that we conduct with several stakeholders from different stakeholder groups. And the dialogue follows a special sequence. We have participants from academia, from the government, from culture and media, from business, and from civil society. So we also have guests from civil society today. And the aim of the Dialog project is to get in touch with civil society and the other stakeholder groups and to work together in a structured and participatory process on issues and problems in the field of cybersecurity. And as I already said, the dialogue follows a specific sequence, and we have this think tank workshop, which takes place once a year. And at this event, we elect the topics for the work streams in which we work together. These are little projects. One of them is called B3 or Bundesbug Bounty, which we are here today, and we have another one that is called Upschooling, and that aims at creating and testing information material on cybersecurity for pupils and teenagers in school. You can find more information if you look in the shared notes. There we have the project website, and I think what do we have? We have else the GitHub and a summary on the project. And now I would like to say thank you to our guests first and to our speakers that are Christian and Brian, and to our moderator, Isabel. And now I would like to pass over to Bianca Kastel. She's the speaker and the initiator of the workstream Bundesbug Bounty. And wish us all an interesting evening and exciting discussions about Log4Shell, not Log4j. That's what I learned today, and its consequences. And thanks for being here. And now pass over to Bianca. Thanks.
Hello, my name is Bianca. I'm the chairperson of the INÖG, that's the Innovationsverbund Öffentliche Gesundheit, and that's a very funny name in German because it's like an innovation network for public health. We are a non-profit NGO that is building open source public infrastructures for public administration and health departments in particular, which was quite some task inside the pandemic you can think of. But our core work is an open source framework called Iris Connect, which is a zero trust data interface for connecting health offices in Germany. So what do we have to do with information security and the Bundesbug Bounty? As an open source project, we are also keen on improving the security of our projects. So we submitted the Bundesbug Bounty, short B3, which is translated best into a colorful bug bounty program. in the annual Dialog for Cybersecurity at the BSE, and we're happy that that it became one of the work streams. And what's the goal of this work stream? How can open source projects learn about their vulnerabilities? We have also some on the next slide some more topics in this workstream. How can we reach the users, and how can we provide an anonymous, ethical, and legally sound and low threshold coordinated vulnerability disclosure process for security researchers? Because right now in Germany, it's a little bit a problem when you find a security hole in something, and you won't find the right person to contact. You won't find the right person to contact the software developer, and it's a little bit a mess, and it's a little bit not so easy in a legal perspective, because in Germany we have something like the hacker paragraph, so you can be it can come into prison if you find a security problem. So we will want to fix that, and therefore we are here to talk to people which have experience in software development or in bug bounty programs. And that's a part of this talk today, talking to people which have experience in this field. So we have also prepared 6 events in Be Free in Dialog, which will follow after this one. Most of them are in German, but there are also some in English. We have the events that are listed on this slide, and we will inform you about the upcoming events on social media and so on. And you're very welcome to the next events, which will happen in a similar fashion like this one. So then I think we have the introduction to Isabel. Isabel will guide us through the whole evening. And I think without further ado, she will introduce our guests today.
So first of all, thank you for the invitation. I'm particularly pleased because I know both Christian and Brian for a very long time. I don't know if we've ever met in person, so I'm currently a director at the Innosource Commons Foundation. In parallel, I'm also a member of the Apache Software Foundation, and that's why I know both Christian and Brian. If you move to the next slide, Christian is a member of the Apache Software Foundation. He's part of the Log4j team, and I know he was very involved with the mitigation of the Log4Shell incident. On top of that, I know him as a freelancer who works with a very deep Java engineering background and who also does trainings for newcomers. In addition, later today, we will have a talk by Brian Behlendorf. I know him as the founder of the ASF. Today, he's a general manager of the Open Source Security Foundation, which is a part of the Linux Foundation. If you move to the next slide. There's the participant involvement path. If you feel uncomfortable posting your questions here on chat, or if there are any feedback, if there's any feedback that you want to give us after the event, there's a link there to our CryptPad where you can post questions, comments, corrections, whatever. In addition, this workstream also has a Git repository where you can use, for instance, the issues in order to post questions or in order to make suggestions. In addition, there's a newsletter, of course, that you can subscribe as well. And with that, I would like to hand it over to Christian. He will tell us more about his experience of Christmas when Log4Shell happened.
Excellent. Thank you, everybody. Thank you for having me. So this is very nice to talk about Log4Shell one more time, because I think Log4Shell is really has become a part of my life for quite a while now, and all here and then people want to talk about it, and I'm very happy that Isabel didn't introduce me as she introduced me as a Log4j developer, so I'm very grateful for that. She didn't introduce me as a Log4Shell developer, so that would be, well, but happens. So what I'm going to do now is I'm trying to share my screen, and I have prepared some slides for you. Let me just see how I can do this. Okay, and I'm playing something here. Okay, good. It's about Log4Shell. You see a little bit of my contact data. So, but before we start, I would like to introduce me to you. So this is me. I had a shaved back then and a good haircut, but this is still me. I'm self-employed, as Isabel said, so I'm running my own company, and I have a wife, a kid, and one horse. Unfortunately, I have to share the horse with my wife. She took the front part where she can, do all the snuggling and this thing. I have the back part. You can imagine it's not so fun sometimes. Anyway, I'm involved in the Apache Software Foundation. It's basically my primary thing, which I do in open source. I'm a member in the Apache Software Foundation, and I'm current VP Data Privacy. So this is a hobby of mine. And yes, I was involved with Log4PHP, Log4j1 specifically, and I did a couple of contributions to Log4j2. So here's the disclaimer. So I'm not really a core developer of Log4j2. If you look at the contribution list, so there is more people or other people who did a lot more, but I'm still with the project. I'm still discussing. I'm still meeting with everybody. I know all these people. So we're like a little family. And that's why I also was getting active on Log4Shell, of course, because I just wanted to help. So before I really start with my presentation, I would like to say thank you to Matt Sicker and Volkan Yesici, or I am not sure if I spelled this right, but he knows who is meant. So these two people helped me to get my facts straight. So they're both very active in the Log4j2 project, and they sent me some links and some information they collected. So thank you them. And well, now I would like to tell you, this is an old slide for a presentation I gave. So it was about, hey, why are you all doing this open source stuff? And I was telling him all this stuff I was saying here. So like lots to learn and making new friends. So I don't need to tell you, so you all know open source. So that's not why you're here. But one aspect is really important. And the aspect is I'm not doing this for money because there is so many other good reasons to do open source. And actually, I never was paid a single cent for any efforts I had with open source. And for me, open source should be fun. And this fun sometimes looks a little bit like this. And I'm a little bit afraid before heights. So it looks like fun. Sometimes it isn't, to be honest, right? So, but it should be. Anyway, so this is an image we all know, or we have seen that. So this is all modern digital infrastructure. And so when 2021 happened, so this was Log4j, and all the other projects, they were building on Log4j, and everybody was using Log4j. I mean, of course, not React and all that stuff, but everybody I know had some problems because of Log4j, and it's really a question. I mean, we are all doing this, for free, so to say, and then something like this happens. So this is not really a good feeling. So, but let us look a little bit about the actual pyramids. So there's the cool and fancy stuff like crypto wallets, NFT was, I don't know if this is still a thing, but online spreadsheets and even Pokemon Mobile. And so you see the slide is a little bit older, so like 1 year old or something. So all these projects, they get a lot of funding and a lot of money. So this is the cool and fancy stuff. So if you say something like, I'm doing it, they throw millions at you. And then we have the impressive technology, like, the building bricks, so to say, Kafka and Mongo and, whatever. So you're also getting money for when you're working on an impressive tech. Then we have something I call the expert world, like you're working on a JDK or you're working on Ethereum VM or things I simply don't know. And this is all well funded because you need to be a real expert. And then we have the real boring stuff, logging. So to be very honest, when I started my career, I was never thinking that I would end up in an open source project, which does not anything else than pushing string messages to a log file, which probably nobody ever reads. So this is, it feels really boring, but in fact, it's really interesting. But it took me a couple of years to find out about this. However, for 13 years, we did not get any funding. So, I mean, this is a library everybody uses, or many people use, but we are not getting any money for that. So we're just working in our spare times. Before the incident, I have heard of a couple of people like getting, $100 or maybe an Amazon gift card or something like this. After the incident directly, we got some big donations, big being like $5,000 or something like this. And 1 year after the incident, I looked at my colleagues' GitHub profiles, and there is still some sponsoring left, like 20 sponsors are around, spread over the various core committees. So you cannot really make a living of that, of course. Well, so that's the financial situation. So it's a spare time project. And now something like Log4Shell happened. I sometimes call it Log4Hell because this was like it felt back then. Let's talk a little bit about this, and because I think this is what you actually wanted to hear. So first, let's get some versions sorted. We have Log4j1, active 2001 to 2015. And it was totally unaffected by Log4Shell. So it was totally separate code base. And I'm saying this because it bite us a little bit later again. And then we had Log4j2, and Log4j2, it started in around 2014, at least with the first release. The code base was starting, I think, in 2011 or something like this. Okay, Log4j is a full rewrite of Log4j1. Log4j2 is a full rewrite of Log4j1. So totally different code bases. We learned from the past. We tried to make things better. And Log4j2 only is affected by this thing. So far, we have around, like, let's say 6 active maintainers. We have a couple of more people like me who are not so actively contributing code, but we are still around. So let's say we have 10 people who are always around, take care of the project, and 6 people who are really doing a lot of coding. Okay, and until 2021, nobody really wanted to talk about Java logging. So that's the truth. So it was like, oh, what are you doing with Java and logging? And everybody was saying like, oh, take logback or take SLF4j or take log4j1 or something. Everybody had an opinion, but nobody really wanted to talk about this. So this was really a boring thing to talk about. Everybody spoke about different things, honestly. So why did we have this incident? So this feature was created in July 2013. I actually looked up the commit today and looked at it. It was feature number 313. It was a contribution from an outside contributor, so a person who is not regularly involved in the project, who is not a member or committed to the Apache Software Foundation. So just somebody who thought, okay, this is a good idea. Please take this, commit to the code base. And we did that in 2013. And a couple of years later, there was a hacker conference. It was Black Hat. And this Black Hat conference talked a little bit about, it had a talk about JNDA injection. That was the timeline. So you can imagine Log4Shell was in the code until 2013, and nobody, recognized it. Okay, and 3 years later, we had this talk on the Black Hat conference talking about JNDA injection. It was about, I think, Eclipse Toplink. This was the example on this conference. But to be honest, I never heard of this Black Hat conference in my life because I'm not really a security person. To be honest, I have no idea of security. So I never heard of this. I never seen the talk. Nobody told me about this. And I know from my colleagues that they also didn't hear about this talk. And even if you would have heard about this, the feature we committed was 3 years old, and it was in an alpha version of Log4j. So probably, I don't know if we would have recognized this as an issue. I also found it very interesting that this issue was in there since 2013, and just, I marked the error a little bit wrong, so it's 2021. Only in 2021 it came up, so please don't tell me that your library is secure because you never found a security issue, because we didn't find the security issue for like 8 years or something like that, and suddenly it popped up. So I suspect there's many more code bases with active security issues which are still not disclosed. Here's, as I already mentioned, another reason why I did not see this, because on the left, this is me, on the right, this is some security engineer. And I know a little bit about security, like in example, the usual things like use prepared statements because it could happen that you are running into an SQL injection or something like this. Use your firewall, all these kind of things, you know. But I'm not really a person who goes to security conferences. And that's a difference to a security engineer, in my opinion, because these people, they are focusing on security. They're going to the conferences, they're trying to figuring out things and all this kind of stuff. I don't have the time for that, really not. I would love to, because it's interesting, but you know, a day has 24 hours, and I'm doing this in my spare time anyway. So how can I really, you know, find the time to improve my knowledge and security as well, so I can see things like this? So this is expert knowledge, just like, you know, software engineering knowledge on the other hand. Okay, here's a little bit of a timeline of Log4j. So how did this really happen? So in November, we have, you know, somebody reported this issue, and the reporter told us, I'm not sure how serious this is, but it's really not good. You should take care of that. And we acknowledged this issue 1 day later. And the reporter told us then, okay, you know, I have checked against several other libraries and frameworks like Apache Flink, Druid, and Apache Struts 2. And Apache Struts 2 is actually a framework which is still used by Apple, in example. I know that, or at least it was used a couple of years back. So we already knew, okay, this is going to be not so good. It sounds really bad. So we discussed a couple of days, and we tried to understand the issue. And I mean, security issues are usually not easy to understand, to be honest. So you have to find out what is the reporter doing. Sometimes even what is he actually saying. So sometimes security reports are like a totally different language. Then you try to understand it, and how can you implement it in your system, and so on and so on. So we discussed, we understood 4 days later, and a couple of days more, we have it even solved, and we created a release. And releases at the ASF, they usually take 3 days or something like that. So you have to put up a vote. So here is our binaries, and then everybody has to check them, and you know, all the checksum things and all these kind of things. This takes 3 days usually. Okay, and after 3 days, we say, okay, that's a release, and we push it out there. So on the third day, the reporter told us that there is a couple of public security groups starting to talk about this issue on social media. So he gave us some links, and we were looking at them, and we all felt that the people, they were not really, you know, understanding how serious this issue could be. So this was, you know, let's call it luck. Unfortunately, and this was not so lucky, the reporter was also able to bypass our fix. So, well, we had to do the thing again, because he was able to, you know, hack our system one more time. So we prepared a new release candidate on the same day, and without, you know, having the 72 hours in place, we promoted the new Log4j release on a fast track. So just after 1 day, because we knew this is serious. And on the same day, or basically the day after, more and more reports came in, and everybody was saying, okay, this is super serious. I could hack this, I could hack that. And we had more and more issues coming up related to this issue, and so we had to prepare more and more releases. Okay, so that's how it all started. And personally, I recognized this was a very serious issue because we have that private mailing list, and usually we are not using it. Usually we are using it only to vote in new committers and discuss these kind of things. Sometimes maybe a legal thing or something like this. But it's usually not used at all, except for security issues. And at this day, when I checked my private inbox, it was just exploding. And I knew this was, a serious thing. And then I heard the word remote code execution. And as you all know, this is very, very bad. Okay, here's a couple of things which we experienced. So the first question, was it a good idea to not pay our developers? And with not our developers, I mean the developers you never see because they're doing open source somewhere, you're just using their code. And everybody was like, okay, we have this issue, we have problems. And what are these developers doing? They're sitting around, so you cannot touch them, you cannot call them, right? So you can send a list to, something to a mailing list, but you cannot really get hold of them. And so apparently we got some emails indicating we're doing nothing, we don't care. But in reality, it was more like, sorry for the animation, by the way, I was just trying out animations on Keynote. So we were running around like chickens, and we were just trying to figure out what to do, how quickly we can do this. And we sent around, tons of private messages. I told you that already. We had meetings on Slack and released, so many, multiple versions. And then we had tons of security reports. Some were duplicated, some were not. Some were duplicates of the duplicates, and some were duplicates of the new ones. So you have to sort them all out, and you have to find solutions. And I know at least of one person who was in front of the computer for 24 hours in a row. That was kind of extreme. So I'm very grateful he did, because he really had a clue of what to do in this case. And what I can tell you is that nobody of us was like, sitting around, going to the beach, having vacation. I know vacation plans were canceled actually. So still we got, I collected a little bit of constructive feedback here for you. So for the English speakers, I have to translate a little bit. So the first one is translated already. It's Log4j team destroyed my weekend. So, and now here comes the curse words. The other one is on the left side is really good. So this person thought we're all cheap people who don't know shit. Sorry, I shouldn't say this word. So who don't know nothing. And Java is just overhyped, and we're stupid, and all these kind of things. And well, very hateful, I would say. And on the bottom, we see a quote from a person who thinks this is all just thought and making panic. So this is a theoretical danger. It's very similar to the COVID pandemic. And when I read this, it was like, oh my god, this is. Do you know this movie Don't Look Up? So this was my Don't Look Up situation. Okay. Well, one of the things I really understood is that people just don't know if they have a problem, and this is a dependency graph from Spring Boot. And when you look at the dependencies, do you know each and any of them? I don't, to be honest. So there is com, sun, iStack. I still don't know what this does actually. So all of these dependencies usually could have security issues, and you don't have them, all. You don't know them all, and you don't check for all of them every time, or do you? And then there is, of course, Linux. and Linux could have installed Log4j as some kind of library. You never find this, or it's hard to find it. And so people called in and asked, do I have a problem? And or we send that, I don't know, let us check. And checking on problems, this can be really tricky and really complicated. Actually, it's also the other way around. So until so around 2020, I got a badge on GitHub. I was what was it? A Mars rover contributor. I still have the badge from GitHub. So it was saying, okay, you wrote code which is now running on the Mars. Maybe it was even the helicopter. I don't know. So, and from 2020 upwards, we were all thinking, wow, Log4j made it to the Mars. And then in 2022, the NASA was very quick to tell us, no, I'm sorry, guys, Log4j is not on the Mars. This was all, it was all not true. So we don't know what's running on our system, but we also don't know the other systems and which may run our software. So it's in both directions, so to say. Also very important or very interesting is you see the spike of activity here by the end of the year 2021. So this is really a lot of work here. So we had these kind of spikes here as well, but this is very different because here we had some formalities, code formatting, and all this kind of stuff. So this is really significant. And the years before, we had of course lesser activity because we thought the framework was mature and safe. Until 2022, we have more activity again. So it seems that an issue like this triggers people to help with coding. So it's not all bad about this issue. Okay, let us check this slide. This is also very, very funny or unfunny, depends on how you would look at it. So this is a screenshot from, I think, yesterday. It shows us that 34% of daily downloads are still using, vulnerable versions. So isn't this cool? So we don't know who is using these versions. There is also no, if you don't code Java, Java is always uploaded to something which we call Maven Central, or in many cases, let's say it like this. And from Maven Central, people just download their dependencies. And there is no way to remove versions which are vulnerable as ours, so you don't want to break builds, right? So people are still downloading it, and I think that's quite a number, right? Okay, so but we also can see that the numbers are going down. So I hope maybe in 2 or 3 years people started to upgrade. I don't know. Okay, here's a couple of questions which we have faced, and some were not so nice. In example, hey, Log4j2 is broken. Shouldn't I use Log4j1? The answer was, no, please don't. It has its own security issues and they are super hard to fix. And you can have deadlocks and it's super brutal. Don't use Log4j1. We don't recommend it. The second question then was, but why don't you, do not restart Log4j1? And in the middle of such a crisis where we're working, so much overtime, so many hours, and our nerves were done, right? So I know from one person who really drank 2 beers every evening to deal with this issue. No, we didn't want to restart this Log4j1 because it has its own issues and it was not affected by Log4Shell. So it was that since 2015, but some people really thought we were not right here and they were really grumpy with us then when we told them that we would not fix 10-year-old security issues. One call was, I'm playing Minecraft. Do I have a problem? And with the last strength I would have, I would call him back and say, play Minecraft. It's okay now because there is a fix, just update. Okay, and of course we got a lot of press coverage. So whenever something is going to explode, press is around and asks you when, how can I join, something like this. And here's one more lesson. I just try to talk a little bit faster so Brian can share his insight. So one lesson I really learned is when you report an issue, it's dangerous. And what I learned about the reporter who brought up this issue, I mean, he did not disclose it, right? So he brought up this issue a couple of days before the whole world imploded, before a friend of mine called me and told me, hey, did you just kill the internet? So this is a person, he's basically a hero to me. And he was working for Alibaba. And unfortunately, he made, let's call it the mistake, right? The mistake to tell us first so we could fix the issue and not tell the Chinese government first. So, and the Chinese government then somehow punished Alibaba, canceled a couple of deals and so on and so on. So, and I think this is a very bad situation, right? Because if you cannot disclose these kind of security issues, which can happen, because you're afraid that something bad is going to happen to your company, to yourself, or something, then nobody will disclose them, and they are there. Our issue was here in the code for almost, let's say, like 10 years or something. Nobody recognized it until 2021. And one of these people who recognized told us the other people did not. They disclosed this on social media. So this could have been much, much more worse. I have heard recently of this case where the CDU, German political party, sued the reporter of a CDU application problem. So I think, what are these people thinking, honestly? So this is dangerous for all their users. This is dangerous to us. And in a world where we're living in cyber wars and all this kind of thing, how can you not disclose, things because you're afraid? So, and studio, this was really a bad move. Okay, we personally have also learned a couple of lessons. This is more related to security. So we will have more opt-in features, and we will provide a modular system. So in the hope that if you're running into such a problem, you can just disconnect the thing just with a configuration. Probably you didn't enable it, so it's probably, hopefully, not so dangerous anymore. What we also have learned is that we cannot rely on people when it comes to updates. So we were, when we were working on this issue, people came and said, okay, we have still Log4j1 in production. And this is end of life 2015, and is known to have lots of issues like that looks. They're still not updating. And I've learned sometimes it's apparently not possible. So far, I haven't seen so many cases where it's really not possible, but apparently there is, some problems. So I don't want to say anything about this, but you cannot force them to update. And as we have seen with the downloads of Log4j2, they will not even update when it's just one minor number or one middle number or something. Okay, and finally, today I consider Log4j2 very safe. And the reason is not because we were so good. The reason is because this issue popped up and so many security experts came and checked out our code. They looked at every line basically and told us literally everything. It was a very bad situation, but for us it was also very good because so many experts came and helped. And I think this was also a very good experience. What we personally learned is that we have to provide better migration paths from old versions. So we had some documentation issues. I hope they are gone now and people more and more upgrade. We also created a specific security list so people can reach out to us directly. I mean, we have a very good security team at the ASF. They are handling all these kind of things. They are participating in a process called the CVE. This is already very good. But we already discussed security issues directly on this list. And after the whole issue, we actually managed to convince one person to join our team. So yeah, it was a very bad situation. But on the other hand, well, people came and helped. And for me personally, with all the pain, this community coming together and helping to fixing this issue, this was a great experience as well. But of course, was a lot of pain. So I think I'm at the end of my small presentation. I hope I gave you some insights about what happened and what emotions came up. A lot of bad ones if you want to reach out. So this is small links. Probably you can download my presentation at some point, where you can also find the image credits. And so that's it for me for now. And I'm trying to unshare my screen again and would like to thank you very much.
So thank you, Christian, for giving this very interesting and insightful presentation of what happened both in 2021, but also subsequently. And with that, I would like to hand it over to Brian with his talk on addressing systemic issues in the software supply chain. Happy to have you here. Take it away. I can't hear you yet. It looks like the tech people still need to enable you to be able to talk, or you still need to press a button so you can talk.
You should be able to see a microphone button and press that one at the bottom.
He doesn't see it. And the logo at the bottom right of his window looks like he joined only as person who can listen.
Usually you can change the audio preferences. You have a button in the middle, and you could switch between microphone and headset.
You may need to reconnect.
Oh, microphone, okay.
All right. I see something changing. Oh, yeah.
Let's try this. Can you hear me now?
Great.
Yeah. Oh, okay. All right, thank you. Great. I appreciate the opportunity to talk with you all today. Christian, I wish I'd been able to be here for the full presentation because you and the other Log4j developers went through heck, I would say hell, I guess, but I over the Christmas holidays a year and a half ago, and the entire world is indebted to you for the work that you all did under tremendous stress. And so I really wanted to thank you for that, but also thank everyone else. I'd like to try to just talk about some ideas that we have at the Open Source Security Foundation about maybe how to avoid the future kind of scenarios like this, maybe in general how to raise the floor on the state of security across open source code, maybe how to think differently about how open source software is being written these days, and really just to plow ahead. And I apologize, I have a very long presentation I'm going to try to squeeze into 20 minutes or less, so apologies if I don't quite get to every word on every slide. But for all of you, I'm sure this is not news, but 97% of commercial code bases out there contain open source code. By surveys done by a number of different organizations, in general, 70 to 90% of the software behind any software product, be that a phone or a car or a website or just any package you might pick up, on average 70 to 90% of that is pre-existing open source code. In most cases, code that was simply absorbed, pulled in from GitHub, pulled in from Apache org, pulled in from a lot of different places, built on top of, pulled in from Maven, etc., built on top of, and allowing the developers to focus on that 20% on top, or 10% or 5%, and have tremendous productivity, but it allows all of us to take for granted what's iceberg below the surface, right, of pre-existing code. It's also worth noting 85% of code bases contain open source software that is more than 4 years out of date. Again, and a lot of this data comes from a report that Sonatype put out last year. They put out every year, called The State of the Software Supply Chain. It's really worth reading. Sneak also does some great reports in this space as well. But these are some pretty daunting stats for people who are not as immersed in open source as Christian, myself, and many of you, I'm sure, for whom this is probably obvious, right? What we're also finding is that the old days of pulling down a source tarball, doing make, install, and running with it, which is what the state of open source software was when I got started 25 years ago, is really no longer the case. Today, people build on top of precompiled binaries, precompiled libraries, precompiled platforms and components, and as we've talked about, just add like their tiny little bit on top and ship it, and take all sorts of things for granted. And you could take those things for granted, such as when pulling the source code off of NPM that's labeled foobar is related to the foobar project on GitHub, right? We could take that for granted before. You can't take that for granted now. Now there's all sorts of new kinds of attacks that are specific to the software supply chain, once you think about it like a supply chain and not just as bundles of source code kind of combined. And there's lots of ways to defeat this, all of which are more evident now that we are building, packages, as Christian talked about, with hundreds to thousands of dependencies underneath that are hard to even for the developers to audit, let alone the downstream consumers of their code. And of course, about 18 months ago, a lot of this went up in flames in this conflagration called Log4Shell. And I do want to emphasize Log4Shell as the term for the vulnerability. Log4j as a project doesn't deserve to be tarnished by what happened. It was really the Log4Shell vulnerability and resulting breach that Christian talked a ton about, kind of his take as an insider about what led to it, what the ramifications were, how frustrating it was to deal with all the folks who showed up. But let me just say, as an outsider perspective on this, Log4Shell raised some questions that I think we in the open source community realized we had to start to provide an answer to. Is open source software's generally good reputation for security actually pretty well deserved? Does this incident demonstrate deep and pervasive technical issues with how we consume and develop open source code? Technical, but also essentially process and social issues as well, and economic issues? Do these issues extend to the sustainability model for open source code? Can we really depend upon all this infrastructure, this 78%, being built by volunteers? Now, we might debate whether these folks are volunteers or not. Most of them are working on code in the service of their employer or in the service of a contract that they've got, right? Basically, most studies that have looked at the econometrics of open source point to the fact that most contributions are being done by developers because they're solving a problem that they're getting paid to solve, right? They're not getting paid to work on Log4j, but they've made a contribution to Log4j in the service of something else they're doing. And that's critical, and that's how open source has been able to scale to tremendous heights. But there's some weakness there. And so we want to get into. And it's really not just those of us in the open source community or even all devs and CTOs or CISOs asking this. We started to hear about this at the Linux Foundation, at the OpenSSF, and I'm sure Christian and others at the ASF and others started to hear about it from the White House, from folks in the European Union, the National Security Council at the White House, to be clear, from the UK's National Centre for Cybersecurity, from the Federal Trade Commission in the US. Also, lots of Asian governments have started to ask about this. Christian noted as well that the Chinese government was not happy with the fact that Alibaba, the researcher there, did the right thing by reporting upstream the vulnerability. We don't have to get into that and kind of China versus the West kind of topics today, but that's certainly wrapped into this as well. So all these people are asking these questions, and in fact, a group in the U.S. government formed a body very similar to the kind of body formed when a plane crashes to try to figure out what was the root cause of a given plane crash, to try to figure out what was the root cause or the root causes that led to the Log4Shell vulnerability and disruption that it caused. They filed a great report. It's not very long. It's about 50 pages long. Published it in July of last year. And it's really a lot to summarize in a very short amount of time. But one of their conclusions was that the vulnerability had been prevented had the developers had training in secure coding practices that, frankly, very few developers ever get in secure software development. It's not a part of any computer science curricula. There's a couple of books out there about how to do it, but and we'll get into a bit how we're trying to affect that. If they had access to security-oriented design reviews, if they had thought about threat models as a formal part of kind of evaluating, the safety of Log4j, and frankly, nothing beats having a third-party security audit, having a group of outsiders come in, as they eventually did after this blew up. A group of outsiders come in to crawl through your code and look for the off-by-one errors, or frankly, look for the architectural issues or the forgotten masses of code that had been contributed by somebody 10 years ago and kind of left to stagnate. Nobody to crawl through that and say, did you really want to have this inside your software? Either here's a clear bug or here's a risky area that if you can't absolutely be certain there's no bugs in, you might want to consider kind of carving out of the program. All right. And some of the lessons learned that they came up with. I'm sorry, this is repeat. Some of the additional take that I'll give on this as well is that my personal take, like the developers working on Log4j, Christian and the others, they are professionals. They write software for a living. They are not, move fast and break things kinds of developers at all, which I think is sometimes the outsider stereotype of people in either Silicon Valley or in open source software. But there is some imbalances out there that are caused somewhat by the motivations of folks working on open source software, where your primary pursuit is fixing bugs or adding features, and it's not often enough in investing the extra time to look for security holes or do the kind of pay off technical debt or do the kind of maintenance work that makes security holes simply harder to find. And I'll talk about that in a little bit. And often that is because open source developers, when they do work on something like Log4j, sometimes they have the tacit approval of their managers or the executives of the business, but often they have to fight with their managers for the time to do the kinds of boring work at a low level that can actually lead to better security. It's also really hard to measure the return on investment of this. If I had a feature and I upstream it into Log4j and I show that to my boss, that's really easy to quantify as a win. If I do something that improves the security of Log4j, it's often really hard to quantify the value of that to my superiors. And that makes it hard to get, to justify the time to be able to work on that kind of thing in open source software. Now, let me come back to the paying for third-party reviews. Third-party reviews, they're expensive at one level. Now, this was not a scientific kind of properly fully estimated thing, but talking to some folks, if somebody had funded a third-party audit of the Log4j code base, given the size of the code base, the complexity of what it does, it would have cost somewhere between $50,000 and $100,000 US. And this, assuming this had been done before the Log4Shell breach, and it probably would have taken to find those 4 CVEs that were ultimately published, let's say another $50,000 to $100,000 to fund the fixes for that. Because if you show up to Christian, the other Log4j developers, and say, "Here's a bunch of stuff that's broken," maybe they'd be incented to go and fix it, and I think out of professional courtesy that they would. But I also think it's important when somebody is paying for vulnerability discovery to also pay for the fixes for that. So generously saying, let's say it would have cost $200,000 to have found these bugs and fixed them before they had become a problem for all of us, right? And to coordinate a disclosure process around them, so people in critical spaces could have had Log4j updated before it became something that was the subject of exploits. So $200K would have saved us a ton of money, right? It would have saved not just the sanity and the holidays of the Log4j maintainers, but of all of those IT teams and all of those CISOs and the boards, that everybody that got sucked into this cyclone called Log4j. Log4Shell. So that would have saved us a bunch of money. Now, we didn't know ahead of time about that, about I mean, hindsight is perfect, 2020. And so I wouldn't be able to tell you who the next one would be, right? I wouldn't be able to say, if you had 200K, where could we spend it? But I might be able to tell you, here are the 100 projects or the 200 projects, each with maybe a 1% chance of being, subject to the next major vulnerability based on their criticality, based on the age of their code base, based on a lack of other pre-existing third-party reviews, based on a number of factors, and I'll tell you about them in a bit. So would it have been worth $40 million to society, right, to go and scan and remediate, remember paying for the bug fixes of 200 open source projects, and to do that each year, right? Undoubtedly, the answer would be yes, right? The question is who pays for that, and then we can get into that in a bit. But as a society, if we could scrounge up $40 million a year, we would substantially drain risk out of the open source ecosystem, because Log4j might have been an outlier. It might have been just this latest example, but these kinds of things seem to be happening with increasing frequency. It used to be OpenSSL that caused these kinds of troubles, and it could be a future one caused by that, or the bind libraries, or by other kind of widely pervasive open source software that is underinvested in, that is kind of left to volunteers to have to keep up, and folks who don't otherwise have the ability to invest in these kinds of things. Taking a step back, talking not just about the kinds of interventions that are appropriate, but in ways to really transform a domain from being one that was very organically kind of built, where it was a very high trust environment, where it was small, people knew each other, so you didn't really have to worry about too much around kind of securing the connections between nodes. Moving from a scenario like that to one where we really have to assume zero trust, where we have to assume a very hostile world, and we have to kind of add some rigor to keep ourselves from becoming vulnerable to these things, just like I pointed those links in the software supply chain before. Transforming that kind of domain is a huge challenge, right? You can't just wake up and say, right, we're going to adopt a whole set of standards, a whole set of processes, we're going to upgrade all the code and be done with it. Instead, you need to think about a process here that is largely around a sequence of phases that start with offering carrots, changing the defaults, and then moving to sticks. And to illustrate this, I want to talk about the way that the web transformed from being mostly unencrypted connections, as it was when it was born in the mid-90s, to predominantly HTTPS, right? Predominantly everything travels over TLS, over public key encryption. And we've substantially hardened not just the banking websites, but websites, even people's personal websites and most websites out there. And that happened not overnight. It happened over the course of about 10 years, where we went from having the little green bar in the URL, or the little green key in the URL space in web browsers telling you this site is secure, to that was the carrots, right? The incentive to start adopting TLS, to changing the defaults when the sites like Let's Encrypt and others who could issue free TLS certificates and provide a basic level of validation for those certificates, or the price came down on other TLS certificates. That shifted the default to the point now where, to the point when that became adopted, where new websites by default would be encrypted and have TLS certificates. And then finally, now we're at the point where on many web browsers, if you try to access a website not using TLS, it pops up as an error, right? It lets you know, hey, this is wrong. So all of this is about how we transform these spaces, and we think a lot about that, about how to map that up to what is still an essential part of the open source software space, which is this concept of duocracy, that everything is done by those who show up, by those who put in the effort. A mandate to simply be more secure, whether by a government or by a foundation or any single party, is really going to backfire unless you think about the incentives and think about these phase changes that really are required. So this is where the Open Source Security Foundation, OpenSSF, really steps in. We were formed a couple of years ago, actually in 2020, by the Linux Foundation to put together and put under one roof a set of initiatives that focused on raising the overall state of security across the open source landscape, recognizing these new kind of threats to the software supply chain, recognizing that existing open source code varied tremendously in quality, and that everybody was well intentioned in open source. Most people are very well intentioned, but simply lack not just the resources, but also a bit of the processes and training to be able to get to better software. And that now that open source code is being used in critical infrastructure, being used in energy grids and government websites and payment systems and all these places that cannot go down, how do we really raise what we're doing in open source to meet that challenge? So we do it through an array of different approaches that are comprised of software, comprised of specifications, and a bunch of educational resources that, generally speaking, try to build capacity out there in the open source landscape and reduce global cybersecurity risk. It is kind of a circus. We have 8 different top-level working groups focused on all sorts of different domains, as well as some associated projects. I'm going to very quickly, because I know I only have about 5 minutes left, go through some of the products that we've developed and things that we hope people use. But it really, we run the gamut from focusing on adoption of best practices to looking at how vulnerabilities are disclosed and coming up with tooling to better support disclosures of vulnerability, to looking at security threats. How do we identify existing ones and new ones? How do we build tools that help make securing all these links in the supply chain simpler and easier, as well as validating and improving software as it sits? We've pulled together a lot of the leads in the different software repositories out there, NPM, PyPy, OpenMaven, others, to try to talk about, how do we improve that last mile of the delivery of open source code? Looking at supply chain integrity, looking at, are there critical projects that really deserve more focus? And then some initiatives like Alpha Meg and others that I'll talk about in a bit. I'm going to scram very quickly through this next set. Some of the products we've created include a concise guide for evaluating open source code on different security parameters if you're looking to consume, as well as a concise guide for developing more secure code, what you should be doing if you really want your end users to have confidence and trust in the proactive work that you're doing to invest in better security in your open source code. These are largely drawn from lessons that we've put into a training course on development of secure software that we've hosted for free at the training portal at the Linux Foundation. You can also get certified against this. This is something we hope every developer picks up. It's only about 15-20 hours of content, and it's about how to avoid the worst mistakes the common mistakes people tend to make that lead to vulnerabilities, like parsing of untrusted user contributed input for things like format strings. We have something called the Best Practices Badge, which is a certification that projects can achieve based on their adoption of a whole set of practices that we recommend that, just like the Log4j devs set up security at logging.apache.org, there's about 100 of these things that we think projects can do that from a process level lead to better security. And then there's an automated tool called the Security Scorecard that looks at a set of heuristics. Do you have test scripts? Do those test scripts adopt test for fuzzing, for example? That is a sign that this project takes security more seriously than others do. And so all sorts of these heuristics that can be algorithmically determined, and we've deployed this and run it against 1 million different repositories to check for all these different kinds of heuristics. These are heuristics that actually work. Sonatype in their State of the Software Supply Chain report actually looked at these heuristics and mapped them to projects that released CVEs over the last year and found that higher scores did correlate to projects with fewer CVEs, which is really cool. And so it's been used as a basis for kind of a race to the top in a couple of communities, like the Cloud Native community, who recently challenged each of their projects to get their security score over 7, which is it's a 0 out of 9, to be able to be a part of the CNCF. We're pulling all this stuff together into something we're building called the Risk Dashboard, which will allow you to see on a basis of an open source project by project, what is the overall picture of risk that this project represents. And even pulling in things like third-party code reviews, pulling in any other data we can find that would speak to the likelihood that there is a vulnerability lingering in the code or unupdated dependencies, right? Christian talked about the fact that it seems like open source projects don't update their dependencies, and that is a tragedy. And there's no forcing function yet that really drives them to do that, because it's a tremendous pain sometimes to update your dependencies. APIs change, that sort of thing. And we've got to create rewards for them to do that. We have some other projects in the OpenSSF I won't be really able to go into. SigStore is a big one. We've also developed something called Salsa, which is about how do you implement a secure software supply chain process, and a bunch of metadata tagging to describe how you do builds in a way that leads to more secure code. We've also published a guide to coordinated vulnerability disclosure, so the next time somebody like a team like Log4j realize that they've hit a bug that is likely to affect a lot of people, how do they turn to how do they manage that process of going from that disclosure to an appropriate fix to try to minimize the amount of disruption that can be caused across industry. So that's a guide, and we're looking at putting some more together. I'm going to stop here because I want to make sure we reserve time for the panel, but there's a bunch of different efforts, including Alpha Omega and others, that are looking at systematically how do we scan and look for vulnerabilities. And I'll end with just 10 seconds on partly as a response to the Log4Shell thing, we put together a plan called the Open Source Software Security Mobilization Plan that called for $150 million in funding that could be put across both some of these pre-existing initiatives as well as some new ones, like an incident response team, as well as shoring up the last mile in the software supply chain, investing in software bill of materials, doing all sorts of things that we in the community, we dug in and said, how could we, in a minimum viable way, go and make a big dent on what we see as 10 different angles on the open source software and really the software supply chain security challenge. We have raised $30 million so far against this. We're currently talking with a lot of funders in this domain to figure out how to move some of these efforts forward. And really, we've engaged quite a bit with the White House on this, as well as in Japan with the Japanese government, hosting events in both locations to kind of roll this out and recruit more funding and more participation. And we're going to continue to build that plan out and build out initiatives within each of those 10 different work streams. And look for opportunities to align that with public policies and ways where public funding can go to direct this. And I want to mention, I'm really happy to see the German government committing to this in the form of investments in a couple of different efforts, such as the Sovereign Tech Fund, which we're talking with quite a bit about some of this effort. So I'll end here. We at the OpenSSF think this is a huge challenge, lots of different angles that are needed to go and tackle this together. We've got really all of industry together to go and do this, but we would love everybody's help in making it go faster and further. And the Log4Shell breach was really just a crystallization of so many different trends and concepts and ideas that we all knew needed to work. Let's see if we can work together to mitigate the chances of the next one. Thanks.
So thank you, Brian, for this presentation. It was very, very interesting, at least for me. And I see a lot of clapping hands in the chat as well. With that, I would like to open the opportunity for people to ask questions. And I would like to ask Christian to come back on stage and to join us for the Q&A/panel session. So you can share questions in the CryptPad. You can also share them in the chat. That's what I have both open here. I would like to kick that off with one question that I heard earlier this morning, and that was about, from the two of you, is there anything that you can imagine that the Federal Office for Information Security in Germany could do to help projects handle these security issues better, or to support open source with security incidents or with avoiding security issues?
So, Brian, I would have hoped you respond first because you're the expert here. For me, I mean, the issue was disclosed to us and it was all private, and suddenly it wasn't. So in this specific case, I don't think there was any support or anything which could have been done, because at some point people went to social media that started talking about it. And I don't know how this was going public. So I don't believe our reporter did that. I don't believe one of our team did that. I don't know. We never will know. On the other hand, I think what Brian really said is when we developers would have proper access to training materials, we maybe would have seen that on ourselves. So that's something. I mean, if you give me a little bit of time and training materials, then I actually would sit down and read through that. And if a government would try to fund people who work in open source or help them to get their trainings or something, probably that would help. Because as I mentioned earlier, I'm not really an expert in security. I know a couple of standards. I know SSL in browsers, good thing, but I really never heard of JNDI injection before the issue, to be honest.
I wanted Christian to go first, just because I was getting bored with the sound of my own voice, and wanted his insight from as a Log4j developer, but as an Apache member as well. But to answer that question, I wanted to step back a few slides in my talk, which I again went too quickly through. I'm sorry. To talk about these 10 different streams of work that we identified in the development of the open source mobilization plan, and this should be thought of as in some ways additive to, in some ways covering some of the work of the OpenSSF. There's lots of places where government individuals could get involved in the OpenSSF if they wanted to, but the mobilization plan was specifically about, if you had enough money to have an impact on something, where could that money be applied to actually move forward? And this is like just a single slide summary of the 10 different streams. It doesn't even do enough to talk about what's behind each of those numbers, so kind of ignore the dollar figure for the moment. But these 10 topics were the ones where we figured that could be the most efficient use of cash to better security out there. And I could walk through each of them, but they do run the gamut from education, like how do we get everybody who calls themselves a software developer, everybody who's delivering code to service a government contract, for example, or every computer science student graduating from a university in Germany with a degree in computer science, right? Like, how do we get secure software development education woven into their certification processes or into the delivery of code? And I think governments have a major role as a consumer of open source code. Forget about their role as, insurer of last resort or representing the public or all that, simply as an organization that uses open source code, right? Commensurate to that usage and the value they receive from it, there's a lot that they could do, not by implementing new requirements or laws or regulations, but simply by paying it forward, right? By making investments into these kinds of things that would benefit returns directly for them, but also for the rest of the world. And I think the folks who set up the Sovereign Tech Fund in Germany understand that, and that's why I'm really happy to see it resourced with, I believe, what is about 20 million euro right now for the next 18 months, but hopefully it could be even more. So part of this is about like education. Part of it is thinking about how do we get a picture of risk across the open source landscape for people who use open source code, and where are the most critical things to try to reduce that risk. Where is the next Log4j that's lurking inside of everything, right? That we just don't realize it. How do we use digital signatures more pervasively to harden that supply chain? There's a lot of great efforts there that need some funding to move forward and really get adopted and become the standard, the same way that TLS has become the standard for securing encryption on the web. How do we look at replacing languages like C and C++, not for every use, but certainly for those critical uses at the network level or in libraries that are included everywhere, so that we potentially eliminate entire categories of vulnerabilities at once, right? And this is something the White House is actually very interested in. How do we move to languages like Go and Rust and even Java for some of these critical languages, again, to try to prevent some of this stuff. We do need an incident response team. Not every project like Log4j has a benefactor or foundation like the Apache Software Foundation, whose security team was really helpful in coordinating the process. There's a lot of critical stuff that's written by a few people in their spare time, and when they need to call in the super friends, when they need to call in some help, who do they turn to for that? It can be a really bewildering and risk-prone experience. So we can solve that by setting up a team that is focused and properly bonded and can keep secrets, so to speak, while things are being worked on. I can go into the other 10. I don't want to consume too much time here, but third-party audits, I mentioned, really a modest amount of funding, more than any one open source project could apply, but less than the cost of not doing it, could really have an impact in draining risk from the system. And others I can go into if there's questions about it, but I just wanted to use this as a template to help folks understand. We've thought a lot about this and would be really eager to have conversations around folks in any government who are interested in figuring out how to efficiently turn modest amounts of cash into much better security across the software landscape.
Thank you for those insights. There's one more question on how can public actors stress the financial part of the story for more political impact? Referring back to the damage isn't cheaper. What have you seen work?
Where public actors could make investments. I didn't get the political angle on that.
So in conversations, how can public actors stress the financial part of that story for more impact? Like, what arguments can you use in order to get the story across that prevention actually is very important? I suppose I don't have any more background in the question right here, but thinking back at commercial software development, typically it's a matter of get the feature out and we will think about security later on.
Well, we've been tracking very closely the development of the Cyber Resiliency Act in the European Union, and also in the United States, the White House released something new called the National Cybersecurity Strategy, both of which actually are very explicit about shifting more of the liability for security onto the last mile onto the folks delivering software. We've enjoyed about 30 years in the software industry, and particularly in the open source space, of being able to disclaim liability and warranty, to be able to say this is software you use at your own risk. If we were making a toaster and we said, hey, this toaster, you're welcome to it, but you use this toaster at your own risk, and if it burns down your house, we're not liable. Well, people would, complain about that, right? In fact, it wouldn't pass legal product licensing requirements. There in the European Union, you have this updates to something called the PLD, the Product Licensing Directive, that shift more of the liability to the makers of software. And then the CRA builds on that by saying, here's a set of things that those liable parties need to do to get safe harbor in case there is a future Log4j. The problem is that shifting the liability to people like the Log4j developers or even the Apache Software Foundation creates costs that there's currently no structure for being able to reconcile. And it increases the risk of folks like Christian to be able to jump in and develop code, and especially in a crisis, if he comes up with the wrong fix for something and introduces a new bug. Well, does he want to take on that liability? Does his employer want to take on that liability? So we have a big problem here with the CRA and the PLD, where that risk that you're putting onto open source projects, even though there's a disclaimer for commercial activity. Well, Log4j is being used in commercial situations with high criticality. And does that mean that the open source developers are liable for developing that? So we've got to find a balancing act here. We've got to find a way, and I think the U.S. cybersecurity strategy makes a better case for this, where the liability is put on the vendors in this space in the context of a commercial transaction, where if Red Hat is delivering to you software and you've got a support contract with them, that's an exchange of value, an exchange in return for the software, that is an appropriate place to put warranty and liability dependencies, right? For the Red Hat not to disclaim those, because they have that commercial relationship. But we've got to figure out a way to make sure that open source developers, open source foundations, the people who are offering this software as a gift don't become subject to that. So that's one part of the answer. Is I do see the regulatory bodies going, well, there's value being created here, but there's some risks and liabilities, and we've got to attach that. The second part of that answer, though, is we really have to talk more about the slide that I opened with, which is how open source software is this dark matter of the software world, of really our digital culture. We are dependent upon it. There is no longer a distinction between the world of open source software and the world of proprietary software. It's all commercial software, and even the iPhone has tons of open source code and would not have been possible without pre-existing open source. So everybody realizes that. Even Apple realizes that. Even banks realize this, and everybody has a role to play in not just getting to benefit from all this open source code, but in paying it forward and returning that gift that's been offered with likewise a gift of improvement of bug fixes, or even if you can't make a technical contribution, just write a check to a foundation like Apache or others. You could support individual developers, but frankly, I find it to be better to support some of the organizations and coordinated processes around this. And then finally, just ending with, I think people need to appreciate this as a phenomenon on the same level of culture and same level of society, right? This is this renewable resource that we should treasure and figure out how to feed and allow it to grow and blossom further, rather than viewing it as a manifestation of Silicon Valley's, unfortunate move fast and break things kind of paradigm. That we just need to kind of bury that concept.
Actually, I was just thinking when you're speaking. So if I would be liable in any case, so like from a legal basis, then I would stop open source. So because it's too dangerous for me, it would risking my family and everything basically. Or I was always thinking, I mean, Log4j, we have 6 people, right? So I was thinking maybe 1 or 2 can help. Everybody helped. That's good. That's a good thing. But what if nobody had the time to fix this bug because we are all on vacation and we don't want to stop this vacation because we are not paid anyway? So why should we do this? And then I'm thinking on many other open source projects, like a competition I have in mind, which is basically run by a single person. So when you're using a tool written, or a library written by a single person who is dealing with this issue, when this single person is maybe also on vacation, or just busy with other things. And I think it's, if we would make software developers liable in a legal way, so they are responsible for what they are doing, and this sounds actually weird now as I've said, so it would destroy open source software. Of course, most of us feel responsible for what we are doing, so that's why we have released a new version. But yeah, maybe we need a shift in the mindset. So people were using open source software for years for free, and they were all saying things like, "Hey, this is free. We take it. Usually, nothing works and nothing bad happens, so we can just take it. So it's all okay. This is all experts, right?" And on the other hand, I think we're facing now a situation where our whole world, we are growing more and more software. Like the iPhone, I think the first iPhone was in 2006. Nobody was using smartphones back then. It's just 15 years or 20 years or something. And now we are speaking about self-driving cars, and you don't want to have Log4Shell in your self-driving car or something. Yeah, so we need to have, everybody needs to be responsible for this software, even when I write it, but it's not my own my sole responsibility, even when I wrote it, right? So it should be somebody who is using it should be there to say, okay, that's nice software, I'm using it, I help you to get a security review or something.
So moving on to the next question, there's an interesting one for both of you. Is there a recommendation for a coordinated vulnerability disclosure process of open source projects? The question directs it towards the OpenSSF, but I would still like to start with Christian, because I know that the ASF project's foundations process is really, really well thought through, lightweight, but still covers even very impactful issues.
Yeah, we have this CVE process in place. So we have a security team where you can report your issues, and they are creating CVEs and so on. There's a very detailed description, so like a step-by-step description of what you should do, what you can do. They're collecting this information. Honestly, when I have a security issue in my project, I just go to them and they tell me exactly, step by step, what I should do now. And when should I disclose? When should I do a release? What should I put in my release? All these kind of things. And I think this is very helpful. So they're collecting them and they are pushing them to the CVE system, which I think is also some kind of global system where everybody can check. So that's what I know. and so far it has worked very well. So, but probably Brian has more insight here.
Yeah, I don't think anybody would propose creating a single central organization for coordinating disclosures. I think open source is a worldwide phenomenon, and there are many kind of centers of community around the open source landscape. And our hope, and so this is why we published the guide for managing coordinated vulnerability disclosure. Is this is a tool that we would hope that the Apache security team, the Python security team, the NPM community security team, that others would pick up, the Node.js community, would pick up and use as a basis for implementing consistently a set of processes that ride the balancing act, because it is a balance between, if you have to disclose something eventually, right? You can't keep it a secret. You don't want to keep it a secret forever, because the bad guys will find something out not too long after the good guys have it, especially if they're fixing things. At the same time, you don't want to publish things on day zero, because then the bad guys have an advantage. They can attack folks before they're updated. So walking this balancing act is really hard to get right, and things change all the time about the right kind of partners to work with or the right processes to use. And there's even questions like, well, if you find a vulnerability and you report it upstream, and that upstream doesn't respond, what should you do with it, right? So all these things are works in progress, and I think figuring out ways for all the security teams to be working from the same playbook or from similar playbooks it makes sense. And then we proposed setting up kind of a default one in recognition of there's a lot of open source foundations that do not have security teams still, believe it or not. There's a lot of that are not as well run as Apache is, or most Linux Foundation projects. There are a lot of critical open source projects that have one developer on them. It's really remarkable, and figuring out how do you provide somebody that they can turn to when they find something that is, likely going to be a bigger issue, or even if they just think it's an issue, right? They just want somebody trustworthy that they can say, this looks like a problem and I think it might be bad. Help me validate whether it is or not. That's why we proposed the creation of an open source software incident response team, just that could be the catch-all for all these other issues. But getting the security teams to talk to each other as well is important. Finally, I'll add, there's a lot of countries that have set up incident response teams. CERT, for example, China has their own, and others. And we think that could serve a role too. I think countries that mandate that you report bugs to them first don't have a realistic notion of how these processes work, or the fact that these systems are global in nature. And unless they came with a very clear, policy that said they will not, try to seize those reports and turn them into weapons, unless there's a very clear notion that everything will be published within the guidelines of a disclosure process, then I would hesitate to turn to them first. But certainly they have a role to play in this, because there's large government users of software, and they deserve to figure out how to be a part of that disclosure process and update systems before things are too widely known.
This one question related to people knowing what they are actually using. Like thinking back to Christmas 2021, I remember even my own colleagues running frantically through all of the dependencies to figure out where they are using Log4j. What are best practices for both for distributors, but also for people running commercial softwares that are using open source, to know what kind of open source dependencies they are using? Because potentially they would be even open to contribute money to projects or to security scans. Do you have any best practices for that? I remember that, Christian, you also highlighted that there is like a ton of downloads still happening to vulnerable versions of Log4j. What would be your message to downstream users of Log4j to get those out of their production systems?
Yeah, basically, probably it's easy. I don't know, but check your POM files. Use tools like Maven to get your dependencies in some kind of a database and collect them there, and try to figure out which ones have security issues. So that would be my approach. Personally, I'm also using tools like GitHub or data security scanners, which can tell you what kind of systems may have security issues. You can run them. set them up in an automated way. So never do this manually, I think, because you forget to do these things, I guess. And yeah, well, don't just include every dependency because you only need one line of code or something. Probably think a little bit about what you actually need and include only that what you really need. And if it's probably done, by one line by yourself, then do it by yourself. Don't treat dependencies as cheap stuff which is lying around everywhere, which you can use or not as optional stuff. So every dependency, I think you need to maintain it like your own software. And it's not just something in the POM file which you can forget. Just think a little bit different about this. And I absolutely know that Brian has some tooling or something around which gets it done more professionally than what I just said.
No, I totally want to. There's a few things to add. One is it is really hard because, as Christian pointed out, like there's so many underlying dependencies to these things and things that embed those other dependencies further that it's become a bit of a mess for folks, and that's. So it's understandable that there was that scramble, and I think if something were to happen today, there'd be another scramble. Part of this is you can't just do a find, get a file listing, and do a grep to look for log4j or whatever, because in certain languages like Java, things get compiled into binaries that you have to have specialized tools to go in and look for those as well. So there are companies like Sonatype and SNCC and others that sell tools that can crawl into and do software configuration analysis and generate reports and show you here are some dependencies being used for which there are known vulnerabilities. There's a site called deps.dev which offers to do the same kind of thing. GitHub has a security scanner now that looks for vulnerable dependencies. So people are starting to wake up to the need for this. I think we'll see open source tooling and the default CI/CD systems start to incorporate this as well. One challenge is that not every CVE necessarily impacts you, even if you're using that dependency. And if you were to try to have like a zero CVE policy, like update things all the time, you would be pushing a couple updates a day. And you might do that in the context of a cloud service, or in fact, there's a company called ChainGuard which offers zero CVE system images for different things that's really worth taking a look at. But it's incredibly hard on average, especially when you're talking about IoT systems or operational technologies, the kind of things that are used to run power plants and manufacturing systems and the like. So there's a balancing act to walk there, and there's some tools that'll help with that from SBOMs, as well as this new system called VEX for being able to attest to, well, we know we have the CVE inside the system, but we're not affected by it, that sort of thing. So there's some tooling that'll help here, but there's also a cultural thing too. As Christian mentioned, if you're pulling in a massive library just to use one function, you might want to reconsider. At the other extreme, if you go and find a 100-line NPM module that all it does is like shift left by a few bytes or something like that, really second guess whether you need that functionality as an included module or just write something yourself, or look for something that is better maintained. One of the real tricks that we don't have great tools yet for, that the risk dashboard will help try to address, is when you're looking at using some open source code as a developer, how do you evaluate whether it's more or less likely to have vulnerabilities in it, to be a problem for you later on? And so on this slide, I just wanted to point, we have a concise guide to trying to evaluate open source projects based on that. There's a lot more depth behind it if you wanted to click through, but that guide should provide some pointers to things. And among them is, how do you evaluate the community around code? This is a big part of the ASF's kind of whole philosophy, is that community over code. Community matters more than code. If you want to avoid using software written by one person, updated once every 6 months, and where it's clearly a spare time at best kind of thing with a bunch of outstanding issues, instead you want to find something that has an active team of maintainers, releasing frequently, and actively curated, so that if somebody does find a security hole, it's more likely to be patched and fixed in a short amount of time than somebody's forgotten effort. So all of these things are things you can do as developers. As enterprises, there's some tools to help with this, but there's a lot more that's coming that needs to come in order to really help enterprises manage the risk of using software, open source and otherwise, and a lot of which I talked about.
Yeah, what I really liked about what you said is you basically said don't panic. So because not CVE does affect you, and that's actually something I experienced. So when this Log4Shell thing happened, and people called in and said, "Hey, I found CVE in Log4j1 related to databases, and am I affected too?" And so what I felt when such a big issue hits, everybody or many people feel some panic growing, and they're doing weird things, updating, without thinking. I think when something like this happens, you just sit down and check your stuff. What have you done? What are you needing? Don't panic. And the other thing is actually, I absolutely fully agree with when I add a new dependency, I check who is building that. I don't take anything into my code, as I'm just checking, is this one person, is this 10 persons? At the ASF, we try to make a release with at least 3+1 votes. So 3 people need to look at this release, and otherwise it's not a release. And I think this is really important, that you look at the people you're trusting your software with, because when you're using Log4j, then you're trusting the Log4j people. And I think this is what people need to understand. And if you don't like us, you better don't trust us. Yeah.
And hopefully we can make it more scalable than having to get to know the developers of every dependency inside your application, because that works when you've got like 6 dependencies, and maybe transitive trust works for like what they include. But there's a whole lot of software out there with hundreds of dependencies, direct dependencies. And so we've got to figure out tooling to help us scale that trust, right? And I mean, it used to be that we trusted people who run servers and the internet enough not to even encrypt email and our web connections, right? Because we were like, well, if you're running the network, you are probably trustworthy, and that didn't work. That didn't scale past 1995. So now we need to do that stuff, and I think the same thing will be true. We have to assume hostile actors in our software supply chain now, sadly, and we have to come up with systems that contain that or measure that risk at the very least.
Yeah, still, when I trust, this one project, I also may trust the decisions made by this project, so this transitive chain. So yes, I agree. So actually, I don't know everybody whose dependencies I am using. So
I would like to dwell a little bit on the question of community over code. I believe the 3 of us coming from Apache, we all know that this is pretty much very important. And someone once told me that a project without a community is a dead, or at least a project very deep asleep. Now, how do we scale that knowledge into organizations? I know that I'm currently working on a sort of like open source downstream checklist for my own employer. But certainly you also have recommendations, Christian, likely for the companies that you are working for, or Brian, for the enterprises that the Linux Foundation is working with. What are best practices to scale that knowledge of what to look for in potential dependencies to figure out what is a good one or what is one that I likely should avoid?
yeah, you can go on. So while I'm thinking.
Oh, sure. I mean, I just went to the next slide of my talk, which was kind of on the provider side. If you're developing the software, here are some things that you can do proactively to try to improve the security of your code and make sure that your users understand that. I do think, Isabel, the larger question is, how do we take what has been informal, very anecdotal kind of information and relationships between open source developers, which has been part of our strength as an open source community, right? And turn them into things that can be measurable, turn them into things that we can assign a score to. So that's like the security scorecards approach, right? Let me just step forward to that. So that the evaluation at scale of whether certain teams are using these practices, whether certain code is following certain practices, can be done at the order of hundreds or thousands or tens of thousands of software packages, not only to help make us smarter at consuming that code, not only to help enterprises at understanding what are the riskier parts of the thousands of modules that I as an enterprise am using across all of my different projects. How do I reduce that risk? And maybe it is by going, oh, there's something called Log4j in here that hasn't had a third-party audit, but is used everywhere. Like maybe I'll put some money towards a third-party code review or something like that, right? But I think it's also there's a party we haven't talked about yet that I have a bunch of conversations with. I'm trying to pull them into what we're doing, which is the insurance industry, right? Cybersecurity insurance, breach insurance, which is big in the States, I assume sizable in Europe as well, because of all the fines that companies face if they get hacked and their personal data is released, personal data of their customers or others. The insurance industry has struggled to come up with a repeatable model for insuring against cybersecurity breaches for all sorts of reasons. One of which is that a lot of these hacks are very highly correlated. Log4Shell hits and it's like a hurricane hits everybody at once, which is really hard to insure against. So they are looking for ways to reduce systematic risks, like that might try to help avoid things that hit everybody at the same time. So they're very interested in things we're doing. But what they're also really interested in is measurement. If you have two companies, one of which takes security seriously and evaluates the security of what they brought in very seriously, and another who they're just pulling stuff off of Maven and NPM and moving quick and breaking things, as the term used, and not really with a lot of process, like the premiums those two companies pay for cybersecurity insurance should be very different. Lower premiums for those who adopt better practices, higher for those who don't. And so if you can measure the risk in your use of open source software and in your own software development processes, and if somebody outside an insurance company can measure that risk and come up with essentially a credit score or a risk score for you as an enterprise, they can appropriately price those insurance premiums, and they can use those premiums as a way to bend those companies towards better practices. If you do this, if you do that, your premiums come down. And I think that is likely to be a stronger force than government regulation when it comes to getting adoption of better practices out there.
Getting back to community over code, I was thinking that I don't think that companies understand what they are doing when they are using open source. Companies are here for making money and being an employer or whatever, these kind of things. They're using open source, and usually when I was working in such companies, they were all saying, okay, use this open source, make a lot of money. And it needs to shift to become part of that community, I think. Companies also need to be part of the community. They need to understand that the software they are using, they are also responsible for fixing that as a company. So it would mean give your employees time to participate, to learn about open source, probably to become a security expert and help open source projects, or to become an open source developer and learn how the process is, and so on and so on. I think when many companies would do that and allow their employees to work in open source as well on company time, then we would have got less hate emails. So everybody would understand that these kind of things happen, so sad that this is, and probably maybe if more contributors would contribute to Log4j, we would have found this issue earlier. So
So for that, I'm very glad to know from FOSS Backstage just last week to have heard companies like Spotify and Ivan stress that they are strategically getting active in upstream open source, because essentially they want to support the projects that their business depends on. Yeah. Because if those projects fail, their business will fail. And that's a mental mind shift that companies have to make.
Yeah, I think this is a very good approach then.
One question that you already started answering in chat is about, besides money, what would have helped Log4j to fix the issue earlier? Mm-hmm. And you mentioned that the Black Hat information would have been nice to have reached Log4j as a project. Now, like, I know both communities a tiny little bit. I've got a background with the German CCC, just teeny tiny little bit, and a lot of background with the Apache projects. And I know that there is not a lot of overlap between both communities. Now, what could a good way of connecting these communities look like? Do we need some people who are in both communities, or what could information exchange look like?
What I have learned, excuse me, go on.
Go ahead.
Okay. What I have learned is we had this issue. We forgot. We have the code. We forgot about the code. Then a couple of years later, there was this Black Hat conference, and they were basically describing the whole issue. But none of us went to that conference. I actually never heard of this conference, so I had no chance to figure this out. But it was good information, and I think what happened at Black Hat conference was some people figured something out. They made a talk about it, and then, of course, because there was this talk, people learned about this, but only the security people. So education also needs to flow in our direction a little bit. So if there was, some communication channel like an email or something, like on the last Black Hat conference, we learned JNDI is an issue. You can check your projects with steps 1, 2, 3, 4, 5. Then we probably would have taken this email and seen, oh my God, these people found out about something new. Let me check if you're affected. And then we learned, and then probably we would have found this. I'm not sure if it would have really helped, because you actually need to do it. So that's the next thing. But at least we would have a chance to learn from this. And my personal takeaway is, as a software developer, I also need to learn more about security. So I mentioned time constraints, of course, because my day is 24 hours like the rest of us. And I have to learn so much about all these software development things. And now I have to add something else apart from my open source activities to learn about security. So that's really hard. But if it's in tiny little chunks, so like an email, probably this would help. I think we are now both software developers and security engineers, so there needs to be more, overlap at some point. I have no silver bullet how to do this, but probably the OpenSSF is now the organization to fix that. So at least that's what I hear from the talk.
Christian, I got involved in open source software early on, and was part of the group that launched the Apache Software Foundation, because here was this web server that the NCSA developers had built and we were using at different places, and I had things that I thought were improvements or fixes, but I really wanted other people to help me find bugs in them, because I was pretty young and did not know a lot about, especially how to write secure code. There wasn't really a guide to that, or how to think about security. So I think none of us have had formal training in this. I was reading early on a Usenet news group called comp.risks, which was often about how software fails, and that became kind of a corpus of wisdom about how to try to be more defensive. But really, I learned a lot by watching the full disclosure mailing list and the OSS disclosures list and these other mailing lists where bugs get reported, and you read what caused security holes in particular get reported, and you read what caused those holes, and you go, oh wait, do we have the same problem in our code? And that's a whole lot of learning that we tried to condense down into this thing. Let me back up to the presentation, although it looks like I can't control the presentation anymore, sadly. But into this 16-hour course for training. Oh, there we go. Thanks. Which was just back here. Yeah, the Secure Software Development Fundamentals course. I think this is something that every software engineer will have to learn, or software developer have to learn as an early part of their learning how to code process, or should learn. It's not a big time commitment. It's as I said, 15, 20 hours, and you can get certified against that. And it's constantly being updated and translated and that sort of thing. But we really tried to figure out what is the smallest amount, and a couple of the CVEs from the Log4Shell situation did touch on patterns that we talked about, such as parsing untrusted user input. So not that this is the silver bullet that's going to solve everything, but I just don't think we have the luxury anymore to think of software development as something that doesn't have to worry about security, for the same reason that if you're a doctor or a lawyer, there's certain standards of practice that are expected, by being able to just use that term and have a job with that as the title.
Yeah, actually, I agree totally with you. So the thing is, it's 14 to 18 hours. So I'm pain-driven developer. Okay, so I'm taking this course now because I know the pain when I don't take this course, and I'm super happy that you brought this to us. The problem, more or less, will be for the people who don't feel the pain. So who are busy with the daily jobs, and they go into the job 9 and come back at 5, and then they have a family, and the employer says, no, this is 18 hours, you could bring us in, so much more money, and security is something other people should take care of, or the customer needs to pay off. So yes, I will take the course, but I'm not sure if so many other developers will take it. It should be part of university education or something.
Yeah.
It needs to be more,
And we come back to something government could actually usefully do
Yes.
here, is implement this as a requirement for certain things, right? To graduate with a degree, or to, serve a government contract that's about delivery of technology or something like that. Yeah.
Actually, we have a couple of things in Germany. So one is called the IHK or IHK, which educates young programmers. I think it's called what is it called? You know what I mean, Isabel. So I think they can influence the education here. So probably they can't influence it so much on university level, but I'm pretty sure on this lower education level they can influence it. And I think if so many young people, even without university degree, can learn something like this, that would be already super helpful, because it would help shifting the mindset from security is something else, or is expensive, or is unnecessary, I do it later, to I learned about security, I know my shit already.
We have 7 more minutes, and I would like to close this discussion on a light note with I don't know if it's simple or if it's a tricky question. If you were to explain to an 8-year-old who asked you what the Log4Shell impact looked like, what would you explain? I'll make it a tiny little bit easier for you and take a example 8-year-old which knows what open source is. And she knows what programming is because she's been programming games in Scratch.
I can imagine who this is. That's a very good question. 8 years old are very special. It's a special age. So what would I say? I would say the impact of Log4Shell. So many people used Log4j for many years without taking care of it, and they left 6 poor souls to maintain it all alone. And a dragon came up, and the dragon wanted to eat everything, and they were still alone and fighting it and waiting for somebody to help, and nobody came. And that's what I learned, and that's why I'm taking a course to educate myself. Something like this. I don't know, I'm not very good at this.
Yeah, the metaphor I would prefer to use was captured very well by this XKCD comic that I'm sure all of you have seen. Well, actually, it was in Christian's presentation, right? About the library maintained by one person in Nebraska, and just that visual of the stack of blocks. I mean, it's the number of blocks there are down by a couple of orders of magnitude, 3 or 4 orders of magnitude, but it does represent there's this inherent fragility to what we're building on top of. We'd like to think we're building on top of stones and mortar and foundations and that kind of thing. And in some cases we are, and in some cases we're moving too quickly. And moving quickly has allowed us to build great things and have a lot of opportunities and do lots of startup companies and the like, but it's also created some risks. And so now we're learning, just like say in like the 1950s, 1960s with the car industry, how they started to introduce seatbelts and other rules that made, again, it was the insurance companies playing a big role in that. as well as companies like Volvo that said, and BMW that said, hey, more security, better safety actually sells products better. This is the kind of same transformation that the software industry is going into, is this recognition along with society that kind of unbridled innovation, it has great upsides, but also some downsides. We need to figure out how to contain and how to improve. And so maybe an 8-year-old would get that. My daughter is 6, and so I think she would get that. I certainly, if I showed her that picture and said, "This is what Daddy builds for a living," she'd go, "Why is that so fragile? That doesn't seem right." And she would be right. So that's where maybe the 6-year-olds and 8-year-olds have something to teach us.
Thank you so much for your time. It was very nice having
Isabel,
you.
I think you're on mute.
Still on mute? Can you hear me?
Yes, we can
Awesome.
hear.
Now
I
it
think you're
works.
on mute.
Thank you for being here, and thank you for having joined us for this session. I would like
Or
to
am I on mute?
end the official Q&A and invite people into breakout rooms or to stay in general.
Christian, can you hear me?
Yes.
We can hear you. So Marcel is setting up some breakout rooms that we can go to. And I think the people hosting us will come back and explain more how to join those breakout rooms.
Hello, this is me. I will now create around 5 breakout rooms, and you can decide in which you want to join. And I would say I give 60 minutes here. That would start now. Should be on the left side where you can decide. Did you see the group rooms?
I can see it, but I don't know who should go into which room. So what's the difference between the rooms? And how long will we go on and continue? And maybe we end the official part, or I don't know what we're doing now. So is everybody in the rooms except for us? Or?
Not yet. I think it's just to discuss in different rooms if you want to.
Yeah, but with whom? Who's in which room?
You can see that in the room selection.
Yeah, actually, to make it easy, I will just join room 1.
Okay.
And if there is somebody who wants to talk to me, we can meet in room 1. See you there. Thank you.
Bin jetzt etwas unsicher, was ich jetzt machen soll. Und ja, verstehe ich. Isabel, bist du noch da? Noch jemand hier im Hauptraum?
Gibt, glaube ich, nicht so viele im Hauptraum,